Hello dear students, welcome back to our YouTube channel. As you know that we are studying about the Laplace transform, in which we have studied the basic definitions, which are piecewise continuity. Then after that we have seen function of exponential order. After that we have seen about the function of class A equations. Then after that we have seen the improper integrals. And after that we have seen the main definition of Laplace transform, and which is as follows. Laplace transform of f of t, where f of t is a real valued function, is equals to integration of 0 to infinity e raised to minus st f of t dt. Correct? And it is the definition of Laplace transform of f of t. Now we are going to find the Laplace transform of basic function. Laplace transform of some basic function. So as we know that we have seen that f of t is a real valued function, so we will start with the function number 1. If f of t is equals to 1, then Laplace transform of 1 will give us, since we know that Laplace transform of f of t is equals to integration from 0 to infinity e raised to minus st f of t dt by the use of definition. Now since we have the f of t is equals to 1, so we will get Laplace transform of 1 is equals to integration from 0 to infinity e raised to minus st into 1 dt. What we have done here? We have just replaced f of t by 1 in the definition, and we will multiply this 1 to e raised to minus st, so we will get integration from 0 to infinity e raised to minus st and dt. Now we have one exponential function e raised to minus st, and we have to integrate that function in the limit between 0 to infinity. So after integration we will get e raised to minus st upon minus s, integration running from 0 to infinity. Since the limits are for t only, so we can write minus s outside, and we can write 1 of e raised to st 0 to infinity. Correct? Now minus 1 upon s as it is, 1 upon e raised to s into infinity minus 1 upon e raised to s into 0, and we will get minus 1 upon s, 1 upon s raised e raised to infinity and e raised to 0. Correct? And since we know that a raised to 0 is equals to 1, that's why we will get 1 upon s, 1 upon, we know that the value of e is 2 point something, 2.71 something, then power of that number will give us infinity, and e raised to 0 means 1, so 1 upon infinity becomes 0, and minus 1 upon 1 as it is. After multiplying we will get minus 1 into 1 upon s is equals to 0, then minus minus becomes plus 1 upon s into 1, that is 1 upon s. This implies that Laplace transform of f of t means Laplace transform of 1 is equals to 1 upon s. Correct? So what we have done here, we have just put f of t is equals to 1 at the place of f of t in the definition of Laplace transform, and we have just integrate that function after multiplication with e raised to minus st and simplified that expression, and we get Laplace transform of 1 is equals to 1 upon s. Similarly, we can find more basic examples. So let's one more example to find the Laplace transform, and that is Laplace transform of f of t, where f of t is equals to t raised to n. Correct? F of t is equals to t raised to n. Therefore, the Laplace transform of f of t is equals to integration from 0 to infinity e raised to minus st f of t dt, and if we replace f of t by t raised to n, we will get integration from 0 to infinity e raised to minus st t raised to n dt. What we have done here, we have just replaced f of t by t raised to n, or we can write this as also t raised to n. Correct? So Laplace transform of t raised to n is equal to integration from 0 to infinity e raised to minus st t raised to n. Now, if we put x is equals to st, correct? We want dt, so dx by s is equals to dt, correct? And t is equals to x upon s. Similarly, as t is equals to 0 for this, then x becomes 0, and when t is equals to infinity, then put infinity here, then x is equals to infinity. So our integral becomes integration from 0 to infinity as it is, then e raised to minus x, and t is equals to t raised to n means x by s raised to n, and dt is equals to dx by s. So we can write it as integration from 0 to infinity e raised to minus x raised to n, s raised to n, dx upon s. This s raised to n into s as it is, e raised to minus x raised to n, as n plus 1 dx. Since it is free from x, so we can take it outside, and as 1 upon s raised to n plus 1, integration from 0 to infinity e raised to minus x raised to n dx. Correct? And since we know that the definition of gamma function, since gamma function is integration from 0 to infinity e raised to minus x raised to n minus 1 dx. So to get here n minus 1, we will get 1 upon s raised to n plus 1, integration from 0 to infinity e raised to minus x raised to n plus 1 minus 1 dx. So it is a definition of 1 upon s raised to n plus 1 gamma of n plus 1. And if n is integer, then we can write it as n factorial upon s raised to n plus 1. When n is integer. When n is integer. So whenever we have Laplace transform of 1. Laplace transform of 1, then we will get 1 upon s, and whenever we want to find Laplace transform of t raised to n, then we will get n factorial s raised to n plus 1, or gamma of n plus 1 upon s raised to n plus 1. It is the main two basic transformation of 1 and t raised to n. In next lecture we will see, or we will try to solve or get some more basic transformations by using Laplace transform. So please remember or learn each and every definition of Laplace transform, in which we have studied about piecewise continuity. Then after that we have function of exponential order, then class A functions, then improper integrals, then Laplace equation. Read and learn each and every definition to understand the basic concept of Laplace transform, and we have calculated the Laplace transform of 1 as 1 upon s, and Laplace transform of t raised to n, which is equals to n factorial upon s raised to n plus 1, or if n is not integer, then we can write it as gamma of n plus 1 upon s raised to n plus 1. And we have enough today. Now please keep watching our videos and stay tuned with us. If you have any query to understand these examples or these theorems, try to comment on this video. I will try to make answer to that questions. Till then, thank you. Bye.